Are you looking to make some gains? Well, you're watching the wrong YouTube channel.
All right, mathletes. So let's go ahead and look at factoring this 1, 2, 3 trinomial. All right. So here we're looking at general factoring strategies. And I know I have a trinomial, but just like our suggestion says, we always want to see, do we have a GCF? And here, notice there's no coefficient that we could pull out, but we could definitely pull out an M. So let's do that. All right. So let's go ahead and let me copy this down. Let me bring this down here so we know what we're dealing with. All right. So let's factor out that M. And that's the biggest, right? That's my greatest common factor. And so I'm going to reduce all my exponents, right? I'm going to reduce all these M's by 1, and then this one's going to disappear. So we're left with 21 M squared minus 4M and then minus 1. Notice because M times that 1 gives me that M right there. All right. So now I'm going to place this on hold, all right? I'm going to forget about it for the minute, and then I'll bring it back at the end. So now you have 1, 2, 3 terms. So now you have a couple options. You could use the AC method or the trial and error method. All right. Let's go ahead and do the AC method. So just as a reminder, what we do is we multiply the first term times the last term. So we end up with negative 21, right? Because you have 21 times negative 1. And then the middle number is always on the bottom. The middle term, the middle coefficient, this negative 4 is in our denominator. Now we're looking for these two mother factors, right? These two factors that multiply to give me negative 21, but at the same time, they give me negative 4. All right, so some of us we're going to take days, some of us will take seconds. All right, so we'll see it's negative 7 times positive 3, right? And again, that might not work, so just multiply it. It better give you negative 21. Add it, and it better give me negative 4. Cool. So what we're going to do is we're going to use these two factors here, and we're going to use that to split up the negative 4. Again, forget about this M that's on the outside. We'll bring it back at the end. So we're left with 21M squared minus 7M plus 3M, right? We split up that negative 4, and then minus 1. All right, so go ahead and copy that down. And now you're going to note that we have 1, 2, 3, 4 terms. So now we could go ahead and factor by grouping. All right, the first two terms, they have a 7M in common, right? I could divide, the biggest number I could divide by is 7, and they both have a 1M in common, all right? And in parentheses, we're left with 3M minus 1. When you divide both of these by that 7M, right? And you could always check it, right? 7 times what gives me 21, 7 times what gives me 7, right? Use that type of logic. These two right here, they have nothing in common. So when they have nothing in common, we factor out a 1. And we didn't factor anything out, so you still have that 3M minus 1. So if you note, now we're in a good place because these factors are the same. So let's go ahead and factor that out. So we'll factor out a 3M minus 1. And of course, when we factor out the 3M minus 1, we're left with 7M plus 1. So here's our first example. And this happened to be a trinomial, and we decided to use the AC method for this one. Let's take a look at the next problem. All right, for this problem, once again, we have 1, 2, 3 terms. So we have a trinomial, and we always start off by asking ourselves, is there a GCF? Well, yeah, I could factor out a y, so let's do it. So let's factor out a y, and you're left with y squared minus 11y plus 24. This one's a little easier, right? And I say easier, I shrink myself, because my leading coefficient's a 1. So whenever your leading coefficient is a 1, that's going to make our work a lot easier. So let's kind of ignore this just like we did in the last problem. We'll bring it back at the end. So what I'm asking you is, because our leading coefficient is a 1, I want these two terms, right, the first two terms, to multiply to give me y squared. Well, we get y and y. And then these two last terms to multiply to give me positive 24. All right? But at the same time, we want them to add up to give us this negative 11. So before I throw any signs, let me try, not that, get the right pen, 8 times 3. Well, 8 times 3 does give me 24, but what signs do I have to slap in front of these to make them add up to negative 11? Well, you got it. Negative 8. All right. And then here again, fastest way on earth to check. You multiply the inner, you get negative 8y. Multiply the outer, you get negative 3y. And these two, when we go ahead and add those two, we better get this middle term right there. And that's our fastest way of checking. So perfect, this works. And what we said is you cannot forget, after you found your factors, bring down whatever you factored out originally. So there's our answer. Let me rewrite it over here. So when I factor this, we got y times a quantity y minus 8 times a quantity y minus 3. So we again saw we had a trinomial. So I like having this little checklist here to make sure I go through all my options. All right, let's take a look at another one. All right, so here, something a little different. Notice now we have two terms, 1, 2. So you know you can't have a trinomial. So these are gone. You know you don't have 4 terms. This one's gone. So it's either difference of squares, difference of cubes, sum of squares. Well, check this out. We have a subtraction. So right away, we know we're not dealing with any type of sums. We said no type of trinomial or 4 terms. So now, how do I know if it's a difference of squares or difference of cubes? Well, first things first, you always look for the GCF first. Always, right? Even on Sunday. So let's look at these. And what I'm going to do is I notice I'm going to be able to factor out a 2. So let me factor out a 2 before we begin, because that's my GCF. And this is where I want to begin. All right. So don't forget about that 2. Let me copy this down here. So we're left with 4p squared minus 100. We're not going to forget about that 2. All right. So hold on to it. All right. So we look at these two terms. What do you notice about 4 and 100? Well, you should notice that the 4 and the 100 are perfect squares. Not only that, but you're subtracting them. So that's where we get the difference. So here we have the difference of squares. And if you recall, let me write down the formula for you again. When you have something squared minus something squared, when you factor that, that's a plus b and a minus b. And my little shortcut is I say what times itself, right, gives me 4p squared. Basically, I just take the square root of 4. So the square root of 4 is 2 and 2. And you always take half of the exponent. So I just get p. Instead of p squared, take half of the squared. So 1. And then we have 100. Well, what's the square root of 100? Good. You're left with 10 times 10. And what you want to look at is our signs are always one's a plus, one's a minus, and the order never matters. So one's a plus and one's a minus. And we're not done yet because I told you don't forget about what? Good, look up there, that 2. So don't forget about that 2. So for our final answer, we have 2 times the quantity, 2p plus 10. I shouldn't say the final answer. I got to be careful. 2p minus 10. All right. So think about this. Why did I change my answer? Because I said this is not the final answer. Well, remember what we're doing. We're factoring. And something that I didn't do that some of you are just going crazy about right now, which is good, is at the very beginning, I said factor out the greatest common factor. And so that greatest common factor wasn't 2 because I wanted to show you something. I could have actually factored out an 8. All right? And when you don't pull out the greatest common factor, you always have to be careful of this. I see it all the time. We're not done yet because look at what do these two have in common? A 2. What do these two have in common? Another 2. So let's factor out both of those 2's. So what I'm going to do is I'm going to move them out to the front. So this was that 2. I'm going to factor out a 2 from here. So that gives me another 2. And then I'm going to factor out a 2 from here, which is another 2. And remember, whenever you're factoring something out, ultimately you're just dividing by what you factored out. So when I divide these by 2's, right, we're left with p plus 5. And if I divide these by 2, we're left with p minus 5. And now these have nothing in common. So now we're done. And like we said, if we would have factored out the GCF from the start, from the beginning up here, we saw that the GCF was 8. And so we get the same answer, except this is a little longer. So my warning to you is don't just pull out a common factor, pull out the greatest common factor. Hopefully that helps. All right, let's take a look at one more. All right, let's look at this problem. Again, notice 2 terms. So let's do some eliminating. We know it's not trinomial. We know it's not 4 terms. We know it's not a trinomial. And so notice that sign in the middle, right? The sign in the middle is a subtraction. So we know we're not dealing with any type of sum. So now we have a choice, difference of squares or difference of cubes. Let's always start with that first step, greatest common factor. So let's go ahead and let's factor out this greatest common factor, which is a 3. Right? So when we divide both those by 3, we're left with x cubed. Notice I have something cubed. So right away I'm thinking it's a difference because subtraction. I'm thinking difference of cubes. Minus 27. And I ask myself, is 27 a perfect cubed? Absolutely. Right? Because it's 3 cubed. 3 times 3 times 3 gives me 27. So right away I know I'm going to have to use the difference of cubes formula. So if you forgot what that is, here we go. Difference of cubes. When you have something cubed minus some other term cubed, right? What you're left with when you factor it is a minus b times a squared plus ab plus b squared. And so it's our goal, right, to find out what our a and b term r. So what we're going to do is, I'm going to forget about that 3, and I want to rewrite this. I'm only going to focus on the x cubed minus 27. And what I want to do is I want to rewrite this as something cubed minus something cubed. Because whatever I end up with in here is going to represent my a, right? And whatever is in here is going to represent my b. And I simply start plugging them into our formula. So I'm just kind of highlighting so you know where you're placing everything. All right. So x, oh, that one's easy. We're just putting an x right there. And then what cubed gives me 27? Well, we just said 3 cubed. All right. So now we have our a and b. And now we just plug it into our formula. All right. So we have x. We said minus b, and our b is 3. All right. And then we have a squared. So we're left with a, and we square it, plus, let me go ahead and throw in these signs right away. And we're left with a times b. So our b is 3, and our a is x. And then plus b squared. So notice b squared, so that's 3 squared, which is just 9. So that's what it looks like when you throw it into the formula. And don't forget, we have that 3 out in front. So let's bring it down for our final answer. So our final answer here is 3 times the quantity, x minus 3, times the quantity, x squared, plus 3x, plus 9. All right, so hopefully that made sense. And hopefully that thinking, you could use it, to go through and factor all these different types of polynomials. All right, folks, let's take a look at one more. And this problem right here is the most important problem in this entire video. And I say it's the most important problem is because this is a problem that you're going to do. So I want you to go back, watch my strategies, and let me know what you think. Does it have a GCF? Comment down below. And then which strategy did you use? Was this a difference of squares? Is it a difference of cubes? Is it a trinomial? Is it 4 terms? Let me know what you think, and I'll have a link down below so you can check your answer. See you guys next time. Peace.